Welcome viewers. In this video we are going to do modeling of transmission line tower in robot structural analysis. In the right hand side picture you can see it is a 220 kV transmission line tower which is a double circuit which we are going to do modeling in this video. This is a stage 1 out of 3. In this stage 1 we are going to look a schematic drawing of this transmission line tower, Excel calculation which we required to find the node positions, node creations in the robot structural analysis, main leg, cross arm and peak member creations, support conditions. So this is in the middle part, it is a hip bracing view which is at 5.5 meter from the ground for this transmission line tower. There is some two level of hip bracing. One is at 3 meter, another one is at 5.5 meter. And in the bottom middle, it is a top view of the tower showing the peak, cross arm, tower bracings and the base of the tower. So let me look into that schematic drawing and followed by a Excel calculation, node creations, main leg, cross arm and peak member creations and support condition in robot structural model. So let me see this configuration of transmission line tower which we are going to model in robot structural analysis. From the left it is a transverse elevation. The tower height is total height is 32 meter, body height is 16 meter, gauge distance is 6 meter, having 3 cross arm for R, Y and B phases respectively. The peak height is 4 meter. The total cross arm distance is 5 meter on both sides. The total is 10 meter. The entire tower height is divided into various segments for bracing member. Start from the ground, it is 3 meter, 2.5 meter, 2.5 meter and the remaining is 2 meter for body height. And the gauge part are divided into 1.5 meter segment for bracing. And after that peak is having 2.5 meter segment. So this is a longitudinal elevation view. So this longitudinal elevation means it is the width of the tower parallel to the conductor span. So for this the conductor used to span in this horizontal direction of this the presentation slide. So that means this conductor span is parallel to the width of this view. So this view can be called it as longitudinal elevation. This is a plan at a cross arm. So you can see that the total cross arm is 10 meter span and the base of the tower is 6 meter on both sides. It is a square tower and the waist dimension is 2 meter. That is a cross arm fixing point. Is 2 meter we are going to consider. This is a section 1 and section 2 view which is taken in the transverse elevation at 3 meter and 5.5 meter from the ground respectively. So this is to show the hip bracing arrangement. So before going to model, we request you to visit our another video which is explaining about the transmission line tower design philosophies. So that video link is given in the description. You can watch those. So let me go to the modeling using robot structural analysis with this schematic drawing. This is the opening page of robot structural analysis 2023. Here you need to click new. In that third icon in the top, frame 3D design to be clicked. So first thing we need to set the job preference. We can consider as a Indian standard design. So the dimensions we can follow SI units, unit of measurements, and materials we can follow Indian standard. Grade of steel is E350. So steel database, we need to add India. If it is not available in this date, we need to click this yellow button and we need to select from this. This is not applicable. Standard loads is also not applicable because we are going to apply manually. Design codes, we need to change this steel and aluminum by clicking this, by clicking this drop down list. Click this more, go to the list where we can find out the Indian standard here in IS 800. Click OK. Here you can see this. And for steel connection also we can check whether it is available in Indian standard. It is not available. We need to do steel connection manually. Then no need to look into the timber, RCC, geotechnical because we are going to design only steel structure. And coming to loads, here already IS 875 is there. We can also check whether IS 802 is available, which is exclusive for design of a transmission line tower or overhead lines. No, that is not available in robot structural analysis. Only working stress method and IS 875 is there. Okay, no problem. We can consider this. And for snow 875 part 3 and 4, wind loads, seismic loads. Of course, the seismic load is not applicable because our transmission line tower is having a flexibility and vibration free structure. So seismic load we no need to consider. So other than that, other parameters are not required. So we can click save current parameters as default and click yes. Okay. And next we are going to create a model. First we need to create the nodes. For that, click this icon which is showing us tables, which is the fifth icon from the bottom right. In this, click nodes full table section. Click OK. So you will see the table of nodes. So in this, we have to prepare an Excel sheet by considering the height, width of the cage, all those information, and from that we need to arrive the nodes position in X, Y, Z. So let me see Excel format. So this is a Excel format which we got developed to calculate the node positions or joint position. So first input we required is a dimension of cross arm. In this bottom cross arm fixing height from ground, mid and top. So this cross arm fixing height we need to enter here based upon the sketch which is showing in the right hand side in both the transverse elevation and longitudinal elevation. So 16 meter, 22 meter and 32 meter is a bottom, mid and top cross arm fixing height from ground. Span of cross arm beam from center line of tower on both sides is 5 meter. You can see in the picture. Width of cross arm at tower is 2 meter. That is a waist width. We can consider as 2 meter. And the dimension of tower top width at the cross arm fixing level is 2 meter. It's a waist dimension. Peak height from bottom of top cross arm from here is 4 meter. So total height is 32 meter from the sketch. And adding this top cross arm fixing height and peak from top cross arm, it is 4 meter. It's 32 meter. So how to calculate the joint coordinates robot is first we are considering this transverse elevation leg number in the left side is a first node which we are going to create as 0, 0, 0 x, y, z. Next one is 6 which is in x direction, this node 6 and 0 0, there is no vertical, so 0 is a z, and y there is no in a longitudinal side. So likewise we need to calculate these four nodes, 0 0 in y direction, all the z should be in 0 is the first node, and 6 0 0 6 6 6. So these are for base, and for bottom cross arm you can see it is in 6 meter. So the center line is 3 meter. This waist we know it is 2 meter. So from center line it should be 2 meter. So we get calculated like this: 6 divided by 2 and 2 divided by 2. So we will have 3 minus 1 equal to 2. So likewise we need to arrange this, and the other node will be from starting from here to this one, it should be 4. So likewise these 4 nodes should be arrived, that is 2 2 2 4 4 2 4 4. So this height is at 16 meter, that is body. Next one is the same dimension we are going to follow for other two cross arms also, for mid and top. Only the height is going to change as 22 28 respectively. And next one is for peak. Peak we are going to create the node in this area, that is ground wire fixing area. So if you want to calculate the node position in x direction, it is nothing but x. So this is span divided by 2, that is at the center line. From center line it should be 5 meter, but from this node point which is the position at 0x, means half of this x we need to consider. Half of the width means 3 meter will come, because it is 5 meter, it is 6 meter. So 6 divided by 2 will be 3 meter. So for the positioning of a peak node and cross arm node, we will look into that drawing format. So in the plan view of this cross section, you can see this node of cross arm or the peak are located exactly in the center line of the tower in width direction, that is in transverse direction. So here is that. So it means the x direction, x we need to consider the parallel to longitudinal direction, that is parallel to conductor span. So it means the x of this point cross arm and the peak lies on mid of this 6 meter. So we need to consider 6 divided by 2, half of this width. So that will be the node point in x direction. And for y direction, if you see, so we are going to consider this as node 0. From here this distance is 3 meter, and in width direction it is 2 meter. So it should be start from 0, it is going in 2 meter this direction, so it should be minus 2. So that is a simple calculation we got made here, that is 5 meters a span from center line, 6 meter is the width of that, base. So this is 6 divided by 2 means this node point will come here. Again, if we are going to minus this 5 meter, then it is minus 2. Similar like other side of the peak and the cross arm, we need to add this 5 meter to the half of this 6 meter span. So it is 8 meter. So likewise, we need to create this node. So this x, y is common for all peak R, Y and B faces of cross arms. Only the change is height is going to change according to the peak R, Y and B faces respectively. So 32 is a peak height, that is the total height of the tower, and from there 4 meters should be deducted, that is 28 meter. From the top cross arm to the middle cross arm there is 6 meter, so 28 minus 6 is 22 meter. And finally for R face cross arm it is a 16 meter. So likewise this node to be calculated, and we can just copy this node and paste to the robot structure model. So we can close now this. So you can see here all the nodes are created. For view this node number, you need to click here. Now we can create the members. So we can assign some section 100 by 100 by 10 initially. So you can also check whether we had selected the Indian standards. Yeah, here from the drop down list, select Indian standard, select SCE, angle member. We can consider 100 by 100 by 10 initially for all the members. Laterally we can change those things. So draw main leg members. So now all the main leg members are drawn. Now draw cross arm. You can select the drag so that it will continually drawing. So we have just connected all the nodes related to the cross arm and the peak. By clicking the drag, the continuity will be there. So now we have connected the peak also. Now we can draw all the possible member to be get connected, like the horizontal members and its bracing member, cross bracing members. So these are the possible without doing any segment or panel dimensions, because to create these members the nodes are already available. So we can draw these members first. So now we have drawn all the possible members. Next we can also give the support condition for these 4 nodes, that is pinned one. So we can type 1 to 4, as we see that only 4 nodes to be connected using pin. Now we are going to draw top of cross arm. So for that we can select this bottom name and press Ctrl C and Ctrl V, that is copy paste. Here you can see it is in 16 meter height, that is in Z direction. We know that we are having 1.5 meter distance here from the bottom of cross arm to the top. So we need to add 1.5 meter here. So it is 17.5. Apply. Okay. So you can see here. Similar like we need to do it for other two cross arm also. Now after doing this copy paste of bottom cross arm to the top, now we need to change or do some small alternation in the peak member. That is selecting this peak member, the node which is connected in 14 to be changed to 34, and similar like 16 to be converted into 36. Similar like this 13 to be 33, and this 15 to be 35. So now we need to add this member, these nodes. So now we can draw the cross arm also. So draw from here 35 to, so we need to draw the top card of cross arm. So the same way we need to do it for all the two other cross arms also, R and Y. So now the cross arm main members are drawn. You can see now in all the other views. After this, we can create the bracing members. So to create the bracing, we are going to follow the picture which is showing in the right hand side bottom. So this picture, by this way, we are going to divide this entire main leg into various segments. Whereas from ground, the first two segment, 3 and 2.5 meter is used to have hip bracing. That is section 1 and 2 are shown in the start of our this video, and the remaining body main leg to be divided for 2 meter bracing span, and the gauge to be divided as 1.5 meter for bracing segment. In the top, the peak to be having a 2.5 meter. So likewise we are going to do it the bracing member. So for creating the bracing member, we are going to do it in another video, that which is a part 2. Have a look into that. Thank you. Thank you for watching. Look at description for more related video. Subscribe to this channel for more updates. Thank you.